Hey everybody, good evening. Today I'm gonna go over the synthesis and pathway we've been working over the last few weeks. Um, in general, it basically explains how the nucleotides and ribose are made from glucose, and they come together to make ATP, which is ultimately used for DNA replication. So I'm gonna go ahead and get started. Okay, so basically, first here's glucose, and basically, as it says here, through glycolysis and several breakdowns, which I'm not gonna go over each one because it's kind of a lot. It eventually leads to pyruvate, which through the pyruvate dehydrogenase complex, which leads to the citric acid cycle, creates acetyl-CoA. Yeah, basically, acetyl-CoA goes through the citric acid cycle, which produces two molecules of carbon dioxide, which are released per turn of the cycle. Three molecules of NADH, which are produced per turn of the cycle. It also produces one FADH2, which is produced per turn of the cycle. And then it produces one ATP or GTP, depending on what organism it is. It's also generated as. And then from the citric acid cycle, it basically NADH and FADH go ahead and release hydrogen ions, which in general is then made to produce ATP. And then going back to glucose, it basically goes to the pentose phosphate pathway, which basically it converts to glucose 6-phosphate, which is an intermediate molecule produced in the initial step of glycolysis. Basically, the PPP branches off from glycolysis at a G6 stage, allowing the pathway to utilize this molecule to generate ribose 5-phosphate, which is a pentose sugar, and NADPH, which are crucial for various cellular processes like nucleotide synthesis and antioxidant defense, respectively. And then basically from the PRPP, we go to the purine synthesis, which basically it provides an activated ribose sugar backbone onto which the purine ring is built, as you can see here. And basically it's the foundation for the entire purine biosynthesis pathway, which is a little bit long, so I'm not going to go into too much detail. But basically, yeah, it's the first committed step involves PRPP, which is converted to 5-phosphorylbenzene by the enzyme glutamine PRPP aminotransferase, which marks the beginning of the purine ring construction process. And it basically leads to two different, as you can see here, synthesis, which leads to adenine and guanine. Now, as mentioned earlier, so CO2 is important. To summarize, not only does glucose lead to the pyruvate dehydrogenase complex, the citric acid cycle, as well as ADP synthesis and the PRPP, galactose, lactose, but it also leads to purine synthesis and nucleotide synthesis. So as you could tell, glucose does go through a lot of different pathways. So it's not just the citric acid cycle, Krebs cycle, etc., but also leads to pyrimidine synthesis, as you can see, which is ultimately what we do daily, automatically, which helps us function, have energy for the day, and things of that sort. And that's it for my presentation. Thank you for your time.